Hi students, in this video I am explaining various concepts for solving numerical of friction. A particle of mass m is placed at the inner wall of a spherical shell of radius r. The coefficient of friction between the inner surface and the particle is mu, that is given, is equal to 1 by root 3. Then at what height from the lower point of the sphere the particle can be placed? So initially the particle is at the lower point. This point is suppose A. Now the particle can be placed at a maximum height here, that is B. If we draw a perpendicular from point B on OA, then suppose this point is C. AC is the maximum height from the lower point where the particle can be placed. Now if we consider the free body diagram, if m is the mass, then mg is the weight acting downward direction. This angle is theta. Now if we resolve it, one is perpendicular and one is tangential component, then this angle is also theta. Therefore perpendicular component, this is mg cos theta, and tangential component mg sin theta. Due to mg sin theta, the particle having a tendency to move from point B to A. Therefore, the frictional force acting tangentially in opposite direction, in this direction, frictional force is acting. So, frictional force this is F is equal to mg sin theta. Now, there is a reaction force acting on the particle by the spherical surface. This is the reaction force R. As the particle remains rest at point B, then the reaction force, this is the normal reaction, is equal to mg cos theta. So we know that friction F is equal to mu into R. So mg sin theta is equal to 1 by root 3 mg cos theta. Therefore, tan theta is equal to 1 by root 3. Therefore, theta is equal to 30 degree. Now we want to calculate AC from this triangle OBC. OC by OB. This is base by hypotenuse. This is cos 30 degree. This is root 3 by 2. Therefore, OC is equal to R root 3 by 2. Therefore, AC, this is equal to OA minus OC. This is R minus root 3 by 2 R. So we can write it R 1 minus root 3 by 2. Three blocks A, B and C, each of mass m, 2m and 3m respectively, are placed over one over another as shown in figure. Block A is fixed with the wall by a massless rod. Block B and C are connected by inextensible string over a massless frictionless pulley. The coefficient of friction for all surfaces is mu. Find the force applied on C to move it with constant speed. Here F is the force applied on C to move block C with constant speed. Therefore, the resultant force acting on block C is 0. We consider the friction here between block A and B. The friction is here. This is F1. Between block B and C, friction is F2, and between block C and horizontal surface, this is F3. As block B and C are connected by string over a pulley, then the tension is acting here. That tension is T. Now at first we have to calculate all the frictional forces. Now first, this is the free body diagram of A. Here mg is the force acting downward. If R is the reaction force, then frictional force F1 is equal to mu into R, that is mu mg. Now for second block, block B, this is block B. The force acting here, this is 2 mg, as 2m is the mass. Here a reaction force applied by block A on block B, that is downward, this is R. And another reaction force applied by block C on block B, this is upward, that is suppose N. From free body diagram of block B, block A, R is equal to mg. Now here N is equal to R plus 2 mg. Therefore, N is equal to 3 mg. So frictional force acting here, this frictional force, suppose in this direction, this is F2. F2 is equal to mu into N. Now this is mu into 3 mg. Similarly, we have to calculate the force acting, frictional force acting on block C, that is F3. The weight is 3 mg. The reaction force applied by block 2 on block C, that is N, in downward direction. The reaction force applied by ground on block C, that is upward, suppose this is P, and frictional force, this is frictional force F3. Here P is equal to N plus 3 mg. The value of N is 3 mg, so 3 mg plus 3 mg, this is 6 mg. Therefore, frictional force F3 is mu into P, this is mu into 6 mg. Now, as block C is applied by a force F in this direction, then the pulley applied tension on block in this direction. Frictional force between block C and ground, that is F3, in opposite direction of applied force, that is towards right, and the relative velocity of block C with respect to block B is towards left. Therefore, the frictional force acting between block B and C, that is frictional force applied by block B on block C, is towards right, that is F2. As block C moves with constant speed, then the net force acting on it is 0. Therefore, F is equal to F2 plus T plus F3. Value of F2 is 3 mu mg plus T plus 6 mu mg. So, F is equal to T plus 9 mu mg. Suppose this is equation 1. If we consider block B, then this is block B. Now block B is moved towards right. Whenever block C is moved towards left, block B is moved towards right. Therefore, the tension applied by pulley through string on block B is towards right. Frictional force between block B and block C is towards left, that is F2, and block A is fixed. Therefore, the relative velocity of block B with respect to block A is towards right. Therefore, friction applied by block A on block B is towards left, that is F1. Now here T is equal to F1 plus F2. So value of F1 is mu mg and value of F2 is 3 mu mg. So this is 4 mu mg. This is equation 2. Now from equation 1 and 2, value of F is equal to 4 mu mg plus 9 mu mg. This is 13 mu mg.